Hey everyone, good evening, guys. Yes, please tell me whatever is the problem, please. I did everything, but whenever I create blank dates and mess with the original, try to predict. It's not predicting. I'm not showing any prediction curve. Okay. Let's see. Let's see, guys. I need to launch the Jupyter again. It got restarted because I had to travel today. Arima and seasonal Arima. Okay, so whenever we make the predictions, we need to give the start and end also, and make sure the start and end what we are giving is for the new dates. Are you doing the same way? Okay. DTF dataset. Okay, that looks correct. Wait, just a sec. Oops. Future date equals to. Okay, yes, looks correct. Looks correct. Let me re-execute it from the beginning so I can check. Just a second. Okay. This is your code, and yes, we are not getting any prediction curve. Okay. I think okay, yes. So why exactly you are not getting the predictions? Because you are making predictions in DF object, right? You are making predictions in DF object. Yes? And you have created the future dataset with F datasets. Yes? So if you make this, it should work. Yes. Yeah, sure. Just a sec. I'll unmute you. Yes, please.
Yeah, hi Abhilash.
Hi.
Yeah, can you please open the assessment one in Simple Learn,
Yes.
that machine learning course?
Yes.
Yeah, this data contains train and test data. So yesterday you have told something, right? So I did the actual same thing you have told. See,
Mhm.
the first question is, if the variance equals to 0, we need to drop those columns, okay? In
Mhm.
train data, around 12 columns have 0 variance. I have
Mhm.
dropped that column. In
Mhm.
test data, around 5 columns as well. But you said whatever we are doing in train, we will do the same in test, right?
Exactly.
So I have dropped 12 columns in test data also.
Perfect.
And second question is null values. There are no null values. It's perfect. And come to third one, label encoder. I did this one. When I perform dimensionality reduction, right? See, I did a PCA test. When I run the test in afternoon, it's showing 217 PC. And just now I did that, and it's showing 147 PC.
Okay. For test data.
Yeah, for test data, I'm doing that components, right? N components. I'm giving that 147 only. I'm not doing the separate PCF for test data.
Okay. So you are doing in train.
Yeah,
So
for train data, it's sometimes it's showing the 217 and sometimes it's showing 147. It's not a problem whatever the piece is. But if I'm doing the same thing in test data also, I'm giving the N component, like same whatever I'm giving in test train data, I'm giving the same in test also. When I'm performing XGBoost, it's showing you mentioned, I think classification algorithm, you mentioned results dot mean. There I'm getting the non-value.
in where like XGBoost
Classification,
regressor.
yeah, yeah, yeah,
In XGBoost regressor, you are getting none in
yeah.
the score or where?
Just for first step only, I think it is. We will do the k-fold model and results, right? There, results dot mean you mentioned. Can you open the classification
Okay,
algorithm?
okay, got it, got it, got it, got it.
Yeah,
So are you using XGBoost classifier or regression?
classifier.
This is a regression problem. We need to use XGBoost regressor here. The target variable is the time here, right?
Okay,
The target variable is continuous. So we need to use XGBoost regressor because this is not a classification problem.
okay. See, after this, we need to fit this model, right? X train and Y train.
Yes.
See, there I'm getting some error like dimensions are not correct.
In training, you are getting error?
Yes. See, we need to split, right? Train and test data.
Yes.
Test we are not going to split, but we need to fit X train and Y train, right?
Yes.
There I'm getting the error. Like, Y should be 1D array, like that.
Okay. So if you are getting this error that y should be one-dimensional array, that means that whatever whatever target variable you have created, x and y, the target variable is not actually in one-dimensional array. The target variable should be only one-dimensional. That is the time feature for us. So whatever we store in y should be only one column. If there is anything more than like that, it will give that error. It will give that specific error. It should be one.
But I'm not going to in that space, right? I'm just fitting the X train and the Y train only.
Okay, so in order to fit X train and Y train, we need to split it into X and Y first.
Yes.
And what is the shape of Y train? Can you tell me the shape of Y train?
Yeah, sure. 1 second. Yes, shape of Y train is 1053 and 147.
Yeah. So it means 1053 rows and 147 columns.
Yes.
In Y train, that is the target variable for the train data. So the target variable cannot have 147 columns, right? Target variable should be the one column only. That is what we want to predict. If your Y train is having 147 column, so that means there's something wrong during the split,
Okay.
right? So Y train should be, I think, what I doubt, where could be a possible mistake. You might have rearranged the elements in train test split. In train test split, it goes like train x comma test x, then train y comma test y equals to train test split, right? First two elements are for training, train x for the inputs, train x and test x. That's the first input. Let me show
Is
you.
there any possible to share my screen right now?
Yeah, I need to make you the presenter.
Sure.
Yeah, here you go.
Yeah. Yeah, let me know when you're able to see my screen.
Sure.
See, this is the train and test data, right? See, this is 378 and
We
277
can't
columns.
see your screen yet.
Sorry.
We can't see your screen.
Oh, 1 second.
Yeah, invisible now.
Yes. See, this is the train and test data. Train data contains
Huge,
37.
huge yellow screen. Actually, we can't see the code.
Okay. Now?
I am not able to see if anyone else is able to see the screen.
Okay. See, sir, it's okay. Then my question is, after doing PCA, I got 147 pieces, right? So, do I need to put that data in fit transform XGBoost, like Xtrain and Ytrain?
Yes,
In fitting.
you need to fit, but Y train should not be having 147 columns. Understand what is a Y train? Y train means the target, what is there, what is the target variable for the training data. So the target variable for training data should be only one dimensional. It should be only one column. Right now, what you are giving in Y train is having 147 columns, and that is the input. That's not the target,
Okay.
right? So whatever, while we do fit function, inside of fit function, the Y train, the second element should be having one dimension only. It should be having one column only.
Now you are able to see?
Yes, now I'm able to see the screen.
Yeah, okay. See, this is the n components. I received this 147 shape.
Okay.
So I'm giving this and I'm doing the shape. This is the extended, and I'm giving the same thing to test data.
Okay.
So now my extended and target this one, like test one, having both columns 147, 147. Is it
Okay.
right or wrong?
XPCA, test PCA dot same, and both have same number of records also, 4209.
Yes. Yes.
Okay, that is correct.
See, and now I'm going to XGBoost. Here I'm
Okay.
giving X as input, right? This XPCA will be input and test
Okay,
will be
okay. I
output.
got it. I got it. I got the problem. See, in cell number 81, you are doing X equals to XPCA, Y equals to YPCA. So what
Yes.
you are doing? You are storing the test data into Y and train data into X, right?
Yes.
That's not exactly what we do. X is the input variable, and okay, let me share my screen and let me explain this. You need to
Yeah,
pass me
sure.
back the presenter rights. Yes. Can you see my name in attendees? You can just click on that presenter icon next to my name.
Sorry.
You haven't passed me the presenter rights yet.
Oh, 1 second.
Um, Not yet. I think you passed to someone else.
I think I have passed right to you only.
No, you have passed to someone else. No problem. Let me call her. Let me let me call Sanya. Oh, okay. Thank you, Sanya. Thank you so much. Okay, see, this is the data set, right? Okay, everyone can see my screen.
Yes.
This is the data set. You transformed it to PCA. So you have 147 columns here, right?
Yes.
So what we do out of this 147, when we do the split on train test split, so this is the train and this is the test, right?
Yes.
So this is going to have some numbers n comma 147 shape, and this is also going to have some x comma 147 shape, right?
Right.
So what you are right now doing, fit, you are trying to fit with this and this data. That's what you are doing,
Yes.
and this is what we don't do. This is x, this is y. When we split, this is called train x, and this is called train y. right? So this is having 147 columns, but y is only having 1 column. And this is what we give in dot fit function. Train x, comma, train y. This is the input and this is the target what needs to be predicted. That's what we do in fit function. Got the difference? Got the problem?
Okay, yeah, I think I got this now. I will do this two-way.
Perfect.
Okay, thank you, Abhilash.
Okay, so now we can start the recommendation engines, right? Have we discussed when the project and assessments are due? The project and assessments will be like we need to finish the project and that assessment after the 15 days to this last class. So this like day after tomorrow is going to be our last class. After that, you have 15 days in order to attempt and submit the projects. Okay. Understood? Yes, please. Let me know if anyone have any question. Yes, please. Okay. So make sure you do not have any number. You do not have anything. Okay. What this error is actually saying, the array should be either between 0 to 1, the minimum value should be 0, maximum value should be 1. If there are some decimal values, or it should be between 0 to 255 if it is integer. If there is anything else in the array, it won't be able to display as an image. So make sure the array is having either the numbers between 0 to 1 or between 0 to 255. Then only it can display as a RGB. In that case, okay, first of all, if you have the data, like if you have the image data itself, the image data is going to be in the same, in the same range, either 0 to 1 or 0 to 255. If there is anything else, the transformation needs to be done as per the array. So you need to identify what color, what number actually explains the dark color or what color actually explains the light color. Based on that, you need to transform that series into 255. That's how RGB color scaling works. 0 means black and 255 means white, right? So if there is anything else, we need to transform that into the specific series, either 0 to 255 or between 0 to 1. In case of 0 to 1, 0 will be black and 1 will be white, right? There is no function or something, you just need to use array manipulation techniques only, Boolean masking or whatever we can use. It just requires a right strategy, what needs to be converted to what value. Correct? So there is a range. Wait. Was it actually an array? Was that an image? So suppose you have 0 to 500, right? This needs to be transformed from 0 to 255, right? So divide the series by something so that maximum value should be 255. Divide this entire series with some value n, so that maximum value should not exceed then 255, or other possible way, if it is 500, just divide the entire series with 500. It will become between 0 to 1. If the maximum value is 500, just divide the entire series by 500. It will become between 0 to 1. With the same, with the same variance in the data. Make sense? Perfect. Yes. Anyone, any questions? Any other questions, please? Little lost. We discussed when the project and assessments, we need to submit them after 15 days of this last class. 15 days after the last class. Okay. Any one project. Yes. If you need any extension, you can raise a request. You can raise a ticket for the same. They are different. You have the project and then you have a simulation test. You have a project and then you have a simulation test. The another one, this project. Okay, let's we can talk about the projects. We can easily talk about the projects. Now for the third project, I have all the three. I would suggest solve all the three projects. Okay, for the third project, there is in self-learning, just go to 10.13 section. Watch this 4 minutes of video. It has the solution of this third project. For the third project, what we have in assessment, mark this section 10.13. 10.13, the third project is completely explained in the self-learning video. Okay? So we can discuss the first and the second project. Yes, Praveen, please let me know what's your question. Yes, tell me what's your question. Haven't did anything. We were just discussing the questions. We haven't, discussed any topic or something. We were just discussing the questions. Any of the three projects needs to be done within 15 days of the last session. Any of the three projects. Clear? But for the certificate of ML, only one project and self-running videos is required. Here also we have the simulation test here. Yes, guys. Here also we have the simulation test. I know it's required. Oh, it's not mandatory. Yes, you can complete them anytime. Okay, good then. That's good then. Okay, so let's discuss the projects. Let's discuss the projects. Though the very first project what we have, the Mercedes-Benz Greener. Yes. What about recommendation engine? What about recommendation engine? Yeah, we will do the recommendation also. We will do the recommendation engine also. Okay, we will do the recommendation engine also. Please explain everything like how to download, what needs to be downloaded. Yes, please let me know where you are, what you are facing. We don't need to down. You have the access to this LMS. You have the access to LMS. It takes to GitHub. So when I'll click on this, it takes to GitHub. Here is a code button and here is a download zip button. Here is a code button and here is a download zip button. Okay. So this will download the entire folder, and from this folder we can search for the Excel sheets, right? The code download zip. It will download this projects folder. From this, like, you can extract and you can find the Excel files. Easy. Perfect. So let's do one by one. The first project. Long story short, there's lots of written on this description. What exactly is the case? We have the input variables, and input variables are the features, are some features of a Mercedes-Benz vehicle, and the target variable is what amount of time that vehicle took on a test bench to qualify the safety test, right? Right. So right now, what is the case here? We have the input variable. Input variables are the features of a Mercedes car, and the target variable is how much time that car took to qualify the security test. So we just need to predict the time what new car will take with respect to the features that car has, so that we can speed up this security test process. That's the problem statement here. So now the data sets what we have right now in this problem, the columns, they are encoded. We won't be able to understand what every column means with respect to a feature. So we are going to treat all the columns on a statistical base only. Make sense? Let me just show you the data set. Okay. So this is the data set where we can simply see we have 4,209 rows and 378 columns, approximately 400 columns, right? 378 columns we have. And we can see these features, these columns are not something we can understand from the business perspective, right? So we are going to treat them on a statistical base only, right? Why is our target variable? ID is just a unique identifier, so we can simply drop X in. We can simply drop ID and Y, and that is going to be our X. Clear? Clear? Then data.y, this is the target variable. X dot had 376 columns as our input variable. Now there is a question. Check for the columns, the variance is equals to 0 and we need to remove those columns. So we can simply check whether the variance is equals to 0 or not by doing x dot var. X dot var function gives the variance of all the columns, right? X dot var function gives the variance of all the columns. Yes? Now we just need to check which all columns have this value 0. So we can simply check xvar equals to variance series. We stored it in a object and we simply did variance is equals to 0 dot index. So these are the columns where variance was 0, right? And we just need to drop these columns from train and test both. Correct? Right? Perfect. So that's the first question. Now check for the null and unique values in the train data set, test and train, and that is something we can do, right? Checking for the unique values for train and test is something we can easily do, right? Next question, apply label encoder. So what all columns needs to be used to do for the label encoder? We can simply check x dot select d types. Oh, sorry, it's capital X. Haven't I executed the code? Yeah, we can see these are the columns that are of object type, and we need to encode all these columns using label encoder. Okay, we just need to encode them using label encoder, and we know how we can do the label encoding, right? Perfect. Okay, explain the complete data set of one project. Complete data set on one project. So what I have done, we cannot talk about the solution. Obviously, I'm so sorry for that. We can't talk about the solution. So what I did, I simply downloaded the project folder, and here it is the folder. Here is the downloads. Here is the project folder. I have downloaded it and placed it in some my directory, right? So we can download the folder and place it wheresoever we want to store, and we can access it using the Jupyter. So here I have the projects folder. I'll simply go to the projects for submission, Mercedes-Benz Greener Manufacturing, right? And datasets for the project. So you can see the path where I have, what I have followed here. And right now I have train.csv file. The zip files were there. I simply extracted the zip files and I have created a notebook to work on the dataset right here in this folder. Okay. Clear? So right here in this, don't need to work on the end project and the practice folder. No, we just need to work on the projects for the submission. These are the three projects what we have right here in these assessments. So these three projects are available in projects for submission folder, right? So you can simply create a notebook file here and start working on the data. Clear? Perfect. Awesome. So these are we good with the questions then? The first question, second and the third question. Delete the columns with variance 0. Check for the missing and unique values and apply the label encoder. Good till here everyone? So whatsoever columns, when we checked, these are the columns with the variance 0 in train. So exactly these columns needs to be removed from test also. We don't need to check what are the columns having 0 variance in test. So these are the columns that has 0 variance in train. These columns will be dropped from test data also. Okay. Perfect. Clear? Then we need to do the label encoder. These are the columns that are in text. So we just need to do label encoder to all the columns. Exactly uniform. Exactly same data structure is required for the train and test. Exactly same data structure is required for the train and test. What if the zero variance column in the train which is to be removed is not the same column in test? It's not possible. Whatever x we have in train, we will be having all x in test also. Okay. Perfect. So good with these projects, good with these questions so far. Now we need to do perform dimensionality reduction. So we need to implement PCA on X. So whatsoever number of components we will identify in X, we will transform the test X to that specific number of components only. Right? Clear? And then we just need to train a XGB regressor. We just need to train for a XGB regressor to get the final model. Clear? No need about percentile, right? We can mention the random number in PC, not the random number. We will be checking the number of percentile in train data. Whatever we get in train, exactly that number we will use in test. Okay. We need to check the 95 percentile thing in train data, and whatever component we get, that exact component we will do on test data. Sure. And then we need to use XDB regressor after this, right? So how we are going to solve the first project? Is it clear, everyone? Perfect. Now let me come to the second project. Okay, so when you will download the second project, again the data is available, and we also have the data dictionary. Data dictionary means what every column means with respect to the problem statement. Now this is again long story short, a lot of written in a problem, a lot of things are written in a problem statement. We just need to predict what is the salary slab, the income slab for a given family, right? Clear? Income slabs. So we just need to predict the exact target class in order to achieve, in order to identify the income slab for a given member, for a given person. Now we have the data dictionary. I think the data dictionary must be already downloaded. Okay. Data description, where every column name is having the description, what exactly it means, right? What exactly this means. What exactly every column means. So this column means dependency squared. Okay. Male, female, less than 10 years old, a free occupied union. So every column has its explanation. Clear? Owns a tablet, number of tablets, household owns, males younger than 12 years of age. So this way we have the information about a family. Clear? Clear? So we can use this data dictionary, the data definition, to understand what every column signifies. Clear? Perfect. Now let's see the questions. Identify the output variable. Let me again open the code for this project. Okay. So we need to identify the target variable. The name of the target variable is target itself. The name of the target variable is target itself. So if we just list down all the variables, we will see the target right here, and that's how we will identify what is the target variable in the data set. So this target is the variable, the column with the name target is our target variable. Okay. Now the next question, check if there is any biases in data set. Now this is something new. What we need to check whether we have any biases or not. Check for the categories, right? What all categorical columns we have in train and what all categoricals we have in test. So ultimately we are going to have the same number of categorical variable in train and test, right? Yes. Perfect. So now what we need to check next, the number of categories in every variable should also be exactly same in train and test, right? The number of categories in every categorical variable should also be same from train to test. If there is a variable, a categorical variable in train, that variable has 3 categories, so it should have only 3 categories in test also. Make sense? Make sense? If there is a column in train, a categorical column is available in train and that has three categories, so the same column in test should also have three categories. Yes, make sense, guys? If there is a variable in train, a variable xyz in train, and the same variable is available in the test, and it's going to be available all the time. So if there is a xyz variable in train and the same variable is there in test, so the number of categories available in that variable should be same in train and test both. It should not be like it is having three categories in train and it is having four categories in test, right? This is called the bias. Okay, this is called the bias. So there should not be any bias, means the number of categories should be exactly same. If the test data has extra categories than that of train data, we need to drop those extra categories. For example, we have the train data, right? It has a variable xyz that has category 1, category 2, category 3, and only 3 categories, right? And again in test data we have the same columns xyz that has category 1, category 2, category 3, but it has one more category, let's say category 4. Now this category 4 is a bias. We don't have the category 4 in train data. So when we pass this data to predict, the model has no information about this category 4 because it was not there in train. So model was not learned about this category 4 and model will simply give the error, right? And not even the model, the transformation, the label encoder or getImage will give the error, right? So we need to identify such cases and we need to drop such categories from test data. We need to identify these things and we need to drop. Okay. There is no algorithm, we need to do it by code itself. No need to do it from split only, just read the train CSV and test CSV and compare them. Okay. Yeah, we will be doing recommendation model. Okay, that is the question about the bias in second project. Is it clear? Perfect. Now the other questions are quite easy. They are the analytical questions. Check whether the members have same poverty level if family had. Okay, now this is a little tricky question, so I can guide you for the this specific question. These two questions are easy. Once you will understand the data dictionary, you can easily do the other questions. This is little tricky, right? This is little tricky. Set poverty level of the members and the head of the house within a family. So we need a right strategy to identify the poverty level. So let me show you how we are going to identify the poverty level. Just a sec. Set the poverty level. Okay. So we will be using the area and the rent paid by that family in order to create the slabs, right? Okay. So there is a column that explains the rent what a family is paying for, what rent a family is paying or a person is paying, plus we have a column that in what area they are staying, rural or urban, right? Rural or urban. So how we are going to utilize that? So let's calculate the median rent for urban and median rent for rural. Okay, if the person is below this, we can simply say below poverty for rural, right? If it is above this, we will say below poverty urban, below poverty urban, above poverty rural. So that's a category, that's a one category. And then above poverty urban. Okay, so use this strategy to create the poverty level. Clear? Clear everyone? Perfect. So that's about the set poverty level. Now count the missing values, remove the missing values, predict the accuracy using random forest, check the accuracy using cross validation. So these questions, I think they are easy, right? These questions are easy, yes guys? Awesome. So that's about two projects. For the third project, just go through with this 10.13 video. 10.13. This explanation has the same exact data set, and they have given the step by step approach. Sure, sure. Fifth point. set poverty level. So in order to set the poverty level, we are going to use the area and the rent. So calculate the median rent in urban, median rent in rural. If the person is paying rent below this value, it is in below poverty rural, that's the category. If the rent is above this and below this, the another category, that is below poverty urban and above poverty rural, right? And if the average rent is above this, make it above poverty. Check if the house is without a family head. So when you will see this columns, there is a column. When you will see the column headers, there is a column that explains the family head is there or not. It's a small, pandas query. You just need to identify. There is a column that explains about. There is a column name that explains about the family head. Just go through these column names. There is a column that will tell you that if there is a head or not. Okay. The father, family member. So you just need to understand the column names. You will see number of children, number of adults, individual. You just need to identify what column explains what, and we will be able to capture whether there is a head or not. Okay. PCA explains X train. You haven't did the standardization. No, X train. It's correct. Or you can. Okay, you did print PCA dot explain variance ratio, variance percent. Let me implement the code. Give me a moment. Let me implement the code. Now, but still it should not be giving this small results. Okay, we have this X, right? So if I just do X numeric equals to X dot select D types, and we want the int only, X numeric. This is the data where I have 368 columns. From sklearn dot pre-processing import standard scalar from X numeric standardized. That's the data set we have right now. Okay, clear till here? From sklearn dot decomposition import PCA equals to PCA and components equals to 0.95. We can directly give like this also. PCA dot fed transform X numeric standardized dot shape. fit transform. I have 144 columns. See, I am getting 144 columns. And in this case, I have excluded the categories. I have excluded the text columns. So there are 144 columns that are explaining 95% variance in the data. Yes? And if I don't use X standardized, still I am getting 72 columns. If I'm not using standardized data, if I'm only using the X numeric, I'm getting 72 columns. We don't need to exclude. I just try to be quick. I just try to implement this code real quick. That's why I just excluded. We need to include them. So can we write the components of variance? Yeah, anything. We can give 0.95 also right here, and we will get the number of components with that specific percentage of explanation. Okay? Perfect. So I hope the projects are good. We can start with the recommendation engine. Perfect. So before we start any technical discussion, let's talk about some basic understanding about a recommendation engine. Okay, what do we understand by recommendation engine, guys? What do we understand by a recommendation engine? Which recommends something. The website, as per our previous experience, recommends Amazon, Flipkart, right? Recommendation of the products. Recommendation of the products. So ideally, we have two types of recommendations. The first type of recommendation is content-based filtering, that what we will be discussing today. Content-based filtering. And another type is collaborative filtering. Okay? Collaborative filtering. Content-based filtering. Content-based filtering. In content-based filtering, by the name itself, it explains it is with respect to the content. It will try to analyze the content, how popular the content is, right? Based on the popularity of content, it will make the recommendations. So if some product or group of some product are very famous or very popular, so that's how it will start making the recommendations. So content based filtering completely depends upon the popularity of the products, of the contents, right? Clear? Collaborative filtering. Collaborative filtering, actually it doesn't directly works on the product, rather it works on the customer behavior, right? It will identify the behavior of a customer, and based on that behavior it will make the predictions or the recommendations. So a small difference between collaborative filtering and content based filtering. Content based filtering is content oriented, in which it will analyze the product, what we are recommending, what we are selling, while collaborative filtering is customer oriented approach, in which we try to analyze the customer behavior. Clear? If there is a new customer, its initial behavior, how it is similar to, or which is our existing customer to which this new customer's behavior is similar. And we will recommend based on those that existing customer's behavior. There is a new customer and we already have a lot of customers. So this new customer's behavior must be similar to one of our existing customer, right? So based on that existing customer's pattern, we will start recommending the products to this new customer. That's called collaborative filtering. Make sense? In content-based filtering, we have the product. There is a movie that get launched and that movie is very much popular. Lots of people watched and rated that movie. And 90% of the people who have watched and rated this movie also watched another movie Y. So based on this movie popularities, there will be the recommendation of movie Y if someone is watching movie X for the first time, because 90% of the people have watched Y after watching X. Make sense? So that's called content-based filtering. Algorithms we use for collaborative and content-based, here we use association rules. Okay, and a priori algorithm. A priori algorithm. In collaborative filtering, we use restricted Boltzmann machines, RBMs. Restricted Boltzmann machines, that's basically a form of neural network, right? Restricted Boltzmann machines, right? It's a form of a neural network, restricted Boltzmann machines, and that's a type of neural network. So we can, for collaborative filtering, we use this neural network based approach, restricted Boltzmann machines, and for content based filtering, we use association rules, that is the a priori algorithm. Clear? Yes, guys, clear everyone? Perfect. All good, everyone? Great. Now let's talk about the content-based filtering in more detail, because that's what we are going to implement today. And collaborative filtering is something neural network-based approach. So we'll be talking about content-based filtering today. Okay. So let me put the heading content-based filtering and association rules, right? Content-based filtering. And that is association rules. Now, what exactly is an association rule here? Association rule means if the person have bought product X, we recommend product Y. That's a simple example of association rule, right? That's a simple example of association rule. Okay. Clear? Yeah, exactly. Association rule is like recommending a product Y if the person have bought product X. So recommending Y over X, that's a simple example of association rule. Easy? Okay, now there are some matrices to evaluate the association rule, right? There are some matrices to evaluate the association rules. What are those matrices? So first of all, first metric is called support. Okay, now let me give you the formula for support. So if there is a rule to recommend Y over the product X, so the support will be frequency of product X and Y together, or frequency of the transaction where product X and Y both were available divided by the total number of transactions N. Okay? Frequency of the transactions where the product X and Y both are available divided by the number of transactions or the total number of transactions. So what exactly support is telling us? Support is telling us the popularity of the products together, right? Right? Support is telling the popularity of the product together. Make sense? Now apart from the support we have a term called confidence. In confidence, yes, N is the total transactions. In confidence, we calculate the frequency of transactions where X and Y both are there divided by the frequency of transactions where X was there, right? So the number of transactions where people have bought X, how many out of those transactions people also have bought Y? That's called the confidence of a given association rule, right? That's called the confidence of a given association rule. Yes, guys? Sure. Support is clear? Support is clear? See, in confidence, the number of transactions where product X and Y both are available divided by the number of transactions where X is there. In, in normal words, what we can explain about confidence, out of the transactions where the person have bought product X, right? Out of all the transactions where the person have bought product X, how many of them have also bought the product Y? What is the percentage of the people who have bought product X? They have also bought product Y. Correct? For example, if you are buying a MacBook from Amazon, if you are buying a MacBook from Amazon, the next product that is something very they definitely you are going to buy after buying a MacBook is a multi-connected port. So that is something 100% of the people are buying, right? Charger, right? If you have bought a iPhone, you are going to buy a charger. Definitely you are going to buy a charging brick. Yes, because Apple is saving environment, so we need to buy a charging brick after buying a iPhone. Yes. MacBook Air, SSD, Samsung. Like this is not very confident rules, but if you are buying a MacBook, you are going to buy multi-connector port, because they're only giving C ports. You need to connect USB or anything else, you need to have a multi-connector port. So that is something you are definitely going to buy. Yes, I would say out of 90-95% of the people who buys who buy MacBook, they will also buy the product Y, that is the multi-connector port of any XYZ brand, but they will buy this product Y as well, right? So the number of transactions where MacBook is being purchased, that is the denominator, and number of transactions where MacBook plus a multi-connector port is being purchased, right? So that's the confidence of recommending a multi-connector port after a purchase of a MacBook. Make sense? Clear, guys? What is the confidence? Now, after the confidence, we have one more metric to evaluate, that's called lift. Now, lift is the support of product X and Y divided by the support of product X into support of product Y. Okay, the support of product X comma Y divided by support of product X into product Y. Okay, so now see, in case of confidence, we were only trying to identify the popularity of the product, that is MacBook, right? Right? In confidence score, if the MacBook has lots of buyers, then only we can have a good confidence. If the MacBook itself is not having a lot of buyers, the confidence could be high, but that's not a good score. For example, let's suppose the total number of purchases are only 2% of the people are buying MacBook, only 2 or 0.1%, or some very small proportion of the people, or very small proportion of the purchase are related to a MacBook. Make sense? So recommending something on that less popular product is not a good rule. Yes, guys? Make sense? Recommending or creating an association rule over a product that's not a very popular is actually not a good rule. Yes? Yes, guys? Does this make sense? Product should be popular. If we talk about recommending rule Y over X, so X should be popular enough. If out of F, let me give you an example to capture this problem statement. Let's suppose the total number of transactions are 1000. Okay, the product X, we have only 2 transactions of product X, and the transactions of product Y are, let's say, 5. But in all these 2 transactions, the product Y is available. So if we are going to calculate the confidence of this rule, we are going to get 1, that is 100% confidence, right? 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 But see, the product X is not even popular. The product X is not even popular. Though we have the confidence of 100%, but it's not a good rule. Right? Though the confidence we are getting is 100, but it's not actually a good rule. It's not a good rule because the product is not even popular. So in that case, what comes into the picture? That is the lift. Okay. Now let's understand the lift. The formula of lift is support of x and y divided by support of x into support of y. Okay, clear? If x equals to 5, y equals to 2, in that case the confidence will be less. Only no, that in that case there will be 40% confidence. In that case there will be 40% confidence, right? How it is one? See what we discussed. The product X was in 2 transactions. The product Y was in 5 transactions. Every time the user is buying X, it is also buying Y, right? Every time the user is buying X, it is also buying Y. So when we calculate the frequency of transactions where X and Y are there, so then it will be 2. And the frequency of transactions where only X is there, that's again going to be 2. So 2 by 2, 1, 100%. Yes? Clear? How is it 1? Perfect. So now let's understand the left, guys. Let's understand the left, guys. Let's understand the left. Okay. Let's take the example that we have. I need to think some good example here. See, guys, the support of x comma y is either going to be less than x and y or equals to x and y. The support of x comma y is going to be either less than or equals to support of x comma support of y, right? It can't be greater than. Support of 2 products together cannot be greater than one individual product. Yes? Right? Right? Clear? Okay, perfect. So now let's take a same scenario. Let's take a scenario where, let's talk about a case where the individual product is not that much popular. Okay? A case where individual product is not very much popular. So I would say if we have the support of, no, let's not use it like support. There is a product X that is occurring in out of 1,000 transactions, out of, let's take 100 transactions, the X is occurring in 20 transactions and Y is occurring in 17 transactions. Okay, right? Suppose. So in this case, the value of support, value of lift, this is a hypothetical example. In this case, the lift will be the numerator will be the support of the product X and Y together. So that's gonna be 0.17, right? Yes? Yes? And 0.2 into 0.17. Clear? Clear? Yeah, but we are not talking about Y alone. If the person have bought Y, like there are 17 transactions where Y was there were 20 transactions in X was there, and in all those 17 transactions where Y is there, X is also there. Just take it this way. In all those 17 transactions where Y is there, X is also there. So we are assuming both the transactions, the support of X comma Y, the support of X comma Y, right, is 0.17. Okay. Now same way, let's reduce the popularity of X. N was 100, but X is now bought only 18 times and Y was 17 times. Okay. So in this case, left is going to be 0.17 divided by 0.18 into 0.17, right? So what we did, we simply reduced the popularity of product X. Yes, in two cases, we simply reduced the popularity of the product X. Rest everything is exactly same. Yes, guys, rest everything is exactly same. We simply reduce the popularity of product X. And is the number of transactions we have in the entire data. Okay, so after reducing the popularity of product X, this should be a better rule, and this should be, this rule should be better than this, right? Yes. The first rule should be better than the second rule, right? And if you calculate the left, this value is going to be smaller than this value, right? This value is going to be smaller than this value, right? Yes. The left for this rule is going to be smaller for the left for this rule. In the second case, left will be smaller, and in this case, it will be, no, in second case, it will be more, it will be greater, and this will be smaller, right? Right? And this is the better rule. This is also a better rule. Yes, guys, this is also a better rule. So left is able to capture the independent popularity of X and Y. That is something the confidence is not able to capture, right? The left is able to capture the independent popularity of the product X and Y. That is something the confidence is not able to capture. Clear? Sorry. Yes, guys. In confidence, we are not able to capture the independent popularity of the product X and Y. But in case of left, we are actually capturing the independent popularity of the product X and Y both. So now left is again, confidence is again a decent enough metric to evaluate the score, evaluate the association rule. We can definitely use confidence, but there is something that confidence is not able to capture. In order to understand that specific thing, we can go with the left. Make sense? Everyone? Yeah, sure. So we had this discussion. After the break, we will do the codes. Okay. After the break, we will do the codes for this. Perfect. No, we are not going to add. We will use lift and confidence, both the values, in order to finalize which rule we should be using for the final recommendation. Guys, this is the very easiest algorithm. The most easy algorithm we will discuss by now. Like till today, what all algorithms we had discussed. So this is going to be the most easy algorithm. We have nothing to do. We understood these three matrices: support, confidence, and lift. We have the data. We will simply create the rules based on the support, confidence, and lift. We will accept or reject the rules. This is as easy as this, right? Very easy and straight. We have these three matrices. We will simply create the rules. We will evaluate how better or how bad the rule is based on the support, confidence, and lift. Clear? Perfect. Let me start the polls. Yes, XP pen. I am using a XP pen. Let me just start the polls, guys. Perfect. The polls are open. Let's get back after. Hey everyone, back. Awesome. So guys, there will be a small social media activity before we continue with the new thing. There will be a small social media activity. So I just want to request Sania to please take over and guide us for the social media activity. Hey Sania, can you hear us?
Yes, sir.
Yeah,
Thank you, sir.
please.
Hi, everyone. Before we resume the session, I would like to request everyone to kindly share your honest feedback on the social media platform that is Career Karma and share your experience about this training. So this is very motivating for us and our trainer, and it gives us energy to do better next time. So I share the URL, the course name and the faculty name in the chat box. Please do click on the URL and sign up on the platform. I request everyone to kindly sign up to the platform using your full name so that we are able to locate your reviews easily. For next 5 minutes, I'll be here to guide you all in providing the feedback. So if you're facing any issue, please do let me know in the chat box. So once you sign up, you'll have to enter your details. Please select status as student. Please select status as student. Next, provide the rating as per your experience. In the review title, please write the course name and the faculty name. You can just copy paste from the chat box. In review title, mention the course name and the faculty name. Yes, yes. So please click on the URL and sign up using your full name. Okay, 1 second, I'm just. Course name is machine learning. Course name, click as machine learning. It kindly refresh your network if you're not getting the option to sign up. Once again, I'm just sending you the URL. Click on the URL. This is a social media appreciation form, Visa. Yes, yes, you can do anonymous review. Nitya, kindly refresh and just click on that URL. You'll get it. Okay, so what you're getting, Vidya, when you're signing up? Email does not match. Just check with any other mail if possible. I don't think there's any other mail. Let's try with that, Vidya. Credentials might be off.
Sorry to interrupt, Sania. There is a query from Leela. I need support, some support for the clarification for my data science project. Who can help me on it? Leela, one method is you can just post your issue in the community. One way is you can post your issue in the community. So whichsoever was your trainer, whomsoever was your trainer with that course, someone from that team or some other trainer or someone can assist you on your community itself. That's the one way, and yeah, that's the only way. So you can was that about this like you said it was about the data science program, right? Yes. So .dat was the that was the project. Okay. .dat file where what is that problem statement? .dat file thing. What is that problem statement? I mean, where exactly you got this question? Yes. Is it there in LMS right here? Can you please help me to navigate that? Where exactly are the .dat files? Yes, please. Where exactly are those dat files? In data science second project, right? So, wait, data pre-processing, should I go to pre-processing chapter or somewhere, or it is in assessments? Movie Lens case study. Okay, can you please help me to navigate where can I find that case study? Is it in machine learning tab or somewhere? It's not in machine learning. It's in data science. So have you on data science with Python? Okay, so you must have covered that particular program of data science with Python, right? So that was a self-paced program, or that was also that also had some live sessions. You must have covered data science with Python module. Was that self-paced or okay? That was self-paced. Wait, I think just a sec. I have right now access to the machine learning specific machine learning tile only, so I need to go for data science with Python one. Okay, yeah. Thanks for the link. Okay, I see. There there were live sessions for this program. Yes. Okay. No problem. We'll talk about the problem and we'll. Okay. Okay. Perfect. Perfect. No problem, guys. We will talk about whatever is the challenges. We'll try to solve it. Otherwise, right now, like we are going on with the live sessions. Right now, we are going on with the live sessions. So we can talk right now. We can get to the solution. But in case once this is finished, at that point of time, if you are struggling or if you are stuck at some point of time, you need the community link in order to post your queries. Yeah, we will talk about that. We will definitely talk and we will get the solution. But right now, see, we are having a live sessions, but we have two more sessions left. And after that, if you got stuck somewhere, then we won't be able to discuss this way. Yes, in that case, you need to use the community. Like in the beginning of every session, in the beginning of every module, it was the machine learning, before it was data science with the Python. You must have received the link for the drive and the community, in which every learner can post the questions and the queries, and some team of trainers, some team of trainers and TAs are active over the community. So we usually used to track. We regularly have an we regularly notice that community forum, in which if there is any question, if there is any problem, any error someone is facing, we try to respond over there. Okay. So right now we can discuss, as we have these sessions going on, but after the sessions are over, you will be having the access to the community only, and that will be the only way to interact, right? Perfect. So just remind me once again, at the end we can talk about what's the issue and how we can get it done. Yes. Sanya, are we left with something or we are done?
Sir, I just need to get confirmation whether it's done.
Okay. Yes, please.
Just
Yes,
give me
guys.
5 minutes.
Are we done with the feedback thing? Feedback done? Perfect.
Thank you all.
Thank you, guys. Thank you, everyone. Now, I hope we can start with the recommendation. Lift, support, and confidence. Is it clear, everyone? Okay, so now what is the next topic? That is recommendation engine. I need to upload the files. I haven't updated anything for the recommendation engines. Drive. This is the one. Today is day 14, right? No, day 13. And I need to upload the recommendation engine data. Recommendation engine. Here we go. Everything is there in recommendation engine. Okay. Everything is there in recommendation engine. Just download the data set and the file. Perfect. So support, confidence, and lift are something we had discussed. So there is also some documentation available for understanding what is support, confidence, and lift. Now we are all good with these three matrices, guys. What is support, what is confidence, and what is lift? Everyone? Perfect. Now, first of all, we need to import some libraries. Okay. Now, in order to use some external libraries, like in this specific case study recommendation engine, we need to use ML Extend. So, in order to utilize ML Extend, we need to install the ML Extend. So, just uncomment this line, exclamation pip install ML Extend, right? Exclamation pip install ML Extend. Just uncomment this file and execute this code. This needs to be done only once because this is the first time we are going to use ML Extend. There are few functions, few classes we need to use for the ML Extend. So we need to install it first and then we will be using the ML Extend. So first of all, please uncomment this, everyone, only one time execution, uncomment the install statement and execute this line of code, this entire cell. So for me, it's already installed, so I can comment it back and I'll simply import the libraries. Okay. Yes, same for the Linux also. Exactly. This is used when we perform the recommendations. Already satisfied means it's already installed. Perfect. So let me know once it's done for everyone. Okay, so we will talk about what is transaction encoder, how it's gonna work, and what kind of output it's gonna give right after when we'll start working on the code. So first of all, we will simply import the grocery store dataset.csv and we will simply assign the column name as a products. Okay. So this is what we have as our data, right? The transactions and what products are there in the transactions. Okay. We have the data related to the transactions and what products are there in the transactions. That's what we have. Easy? Yes, each row in is one transaction. Okay. Yes. So in this first transaction, whichever was the customer, that customer bought these three products. In the second transaction, the customer bought these four products. And yeah. Clear, guys? So if we check, we have around 20 records, right? If we check, we have around 20 columns. Clear? We have 20 columns here. Clear? Okay. Now, in order to do the transactional transformation, we want our data like this. Okay, we want our data like this. So first transaction, the column name for every specific product. So we had like whatsoever number of products we have. So that will be the different number of columns, and we will be just having yes or no whether that product was available or not. Okay, we want our data in this format. We want our data in this structure. No, it's not a label encoder. We just want our data. This is basically a transactional encoder, right? This is transaction encoder. We want our data that each and every column should represent a specific, product, and the information in that column should be whether the product is available in a given transaction or not. So if we see the first transaction, biscuit was there, Bonvita was not there, bread and all these products were not there, milk was there, bread was also there. So that's how we want to transform our data. Clear? In order to achieve such transformation, we need to implement transaction encoder. We need to implement the transaction encoder, and transaction encoder will take the data as a list of lists, right? We can see the first transaction that has the list of products, second transaction has the list of the products, another list, third transaction has another list of products, right? Yes. And how we can transform the data to such format like list of list in multidimensional list by simply utilizing this function. Clear? Let me explain it. We have df products. This is the data, right? These are the products. Remember the apply function. We can simply do apply, and inside apply we can give the lambda function, lambda x return x dot split space comma. So now it is giving the list of the products. Yes. Right, and if we convert this to the list itself, if we convert it to a list, everything will be returned as a list of lists, right? Understood this code? Now let's store it as data, and this is our data. Clear? Awesome. So the way we used to do label encoder, the way we used to do the one hot encoder, similarly we will be doing the transaction encoder here. Created an object for transaction encoder TE and simply did the fit transform. Okay. Created an object for transactional encoder TE and we simply did fit transform. And we convert it into the list directly. We want it as a list of list. So if we want it to have if we need to have like a list of list, then we need to utilize this lambda function. Okay. Clear? Awesome, guys. So after we do dot fit transform, see, this is what we are getting. We are getting the data in true and false, right? Yes. So this is about the first transaction. This is the boolean. Now let's make it more organized to understand. Okay. So if we see te dot columns, it is returning all the products, right? Te dot columns, it is returning all the products. Yes, all the unique products. Now, see what we are doing. Let me remove dtype int first. What we are doing, we are simply organizing it into a data frame. pd.dataframe.fit transform, it was returning true, false. We placed it as a values and we specified the columns equals to te.columns means individual products. And this is what we have as our data, right? Oops. Make sense? Now, if we convert it as integer, so it will become simple zeros and one, right? And this is what we expect. This is the data what we want. Clear? Now, all those things what we have done in steps, we have simply completed everything in a single cell, and this is our DF. Okay, this is our DF. Easy? We have generated, we have created the data set. Understood? Yes. Now we can use this data for the further analysis. Let's see what's next. So this is the data frame. Now if I simply calculate df.sum, it will tell us in how many transactions the product was available, right? This will simply tell us in how many transactions each and every product is available. Okay, now if I divide it with the total number of transactions, if I divide all the numbers with total number of transactions, I will get the support value. See this, df.sum divided by dot shape 0, it is the support value. Clear, everyone? Perfect. Now the support, we have just created it in a data frame and arranged it in descending order, right? So I've just created this in data frame and in a descending order. Clear? Clear, guys? So this is the support value for all the products. Okay. Now here is something that we need to decide, and that is again a subjective approach. We need to remove those products that are not popular. We need to remove those products that are not popular. How we got the support value? The total number of transactions in which the product was available divided by the total number of transactions we have in the entire data. This is how we got the support value. So first of all, we calculated in how many transactions each and every product is available. Then we divided it with the total number of transactions, and this is the support, right? Yes, we simply calculated how many transactions each and every product occurs, and we can simply divide it with the total number of transactions we have, that is 20, and that's the support of every product, right? That's the support of every product. Easy? Perfect. And same thing we have done here, and we are getting it in a more organized manner, right? We are getting it in a more organized manner. Clear till here? Perfect. Now, we simply need to drop the products with less popularity. And how we decide what is the less popularity? Based on the entire distribution about the popularity, we can take a call what should be our threshold to drop the product as a less popularity, right? Now the step should be we need to drop the products with less popularity or less support value. Support is the popularity itself, right? Support is nothing, support is the popularity only. So we need to drop the product with the less popularity or the less support. Now how do we decide what exactly we can consider as a less? Because if if the maximum support what we are getting in the entire transactions is 10% itself, so in that case, the threshold is going to be very less. But if the maximum support is 90%, then the threshold is going to be a little higher. Yes? Right? Exactly. With respect to the overall values, like what is the maximum, how many products we are having. So, uh, like, if we try to, look for a good to follow rule, we can use the percentile method, right? We can use the percentile method. Anything below 10 percentile value can be dropped as a less popular products, right? Make sense? Make sense, guys? We can use percentile approach to decide the benchmark while dropping the products. Support is this. The frequency of that specific product divided by the total number of transactions, how popular the product is, right? It will be how popular the product is. That's the support. Clear? Perfect. So right now we are simply calculating the popularity of every product, and we simply need to drop the product that's not popular enough. We simply need to drop the product that's not popular enough. Simple. Clear? And how do we decide which product is not popular? We can use the percentile of the popularities, percentile of the support, and anything below 10 percentile we can use as a we can use a threshold, and we can drop the products below 10 percentile value of the support. Make sense? 10 percentile, 20 percentile, this is a subjective approach. It completely depends upon how quality, how quality rules we want to have. Do we want to include the products that are not very much popular or not? Clear? DF sum, I'm getting type error. Sum divided by shape 0. Okay. Can you check your DF? Can you tell me the shape of your DF? Can you please tell me the shape of your DF? (21). So the DF is correct. And please execute the DF only. DF dot sum. Are you getting a result like this? DF dot sum. Is it giving the result like this? Okay. Please execute the code again. I don't see there is anything wrong. It should run. Please execute it again. If DF is exactly same, so it should not give any type error. Type error means we are trying to divide string with integer. But if this is a string and integer. Okay, let me explain the error. What error is explaining? We are dividing it with shape 0, right? So unsupported operands means the division cannot be done with the string and integer. So make sure df.sum is also returning integer and df.shape0 also returning the integer. What error you are getting is any of these two values is a string. Any of these two values is string. So make sure we both have the integer. Yeah, can you please check once again if df.sum and df.shape0 both are returning the integer value or not? Okay, can we drop jam? We can definitely drop jam. Or in this case, we are dropping everything that is below 0.15. Okay. It depends, not very necessary to drop, but it could be a requirement, means we don't want to include the products that's not popular in our association rules, right? Clear? At the end of the showing D type N64. Yeah, also N64 or float 64. Sorry. Yeah, N64 here. Float 64 is after calculating the support. Perfect, guys. Is it clear till here? Dropping the support, dropping the products with some minimum support values. Is it clear, everyone? Okay. Okay. Perfect. Now, after this was the data. No, object cannot be converted to int, but boolean can get converted to int. If it was boolean, it would have converted it to integer, but object cannot be converted to integer. Okay, now let's see the next step. The a priori function. The a priori function is simply returning the all possible combination of the products with the minimum support value, right? Like cornflakes, coffee and biscuit. These three products together have 10% of the support, right? So like this, all the possible combination of the products, it is returning what all the possible combinations are there. And we simply said minimum support is 10%. So we just want to get all the possible combinations above 10%. Okay. Make sense, guys? We are simply extracting all the possible combination of the products where popularity is greater than 10%, right? Yes, guys, is it clear? A priori function, what we are getting in a priori? Yes, guys, can I please get a confirmation what we are getting in a priori? Exactly, exactly. Okay, so whatever we are getting here, we are simply storing it in a frequent items series, frequent items data frame, and we have arranged the frequent item in a descending order of a support. Yes, yes. So now these are the combinations of all the products where support is greater than 10%. Now here is the catch. Easy and very straight. There is a function named association rules in which we will simply specify the frequent items what we have received after using a priori. These are the items. This is the frequent items product. Frequent items data frame. Specified the frequent items. Now, what metric we want to evaluate? So we are using confidence and minimum threshold is 0.5. So now what this function will do, it will take the products from this table. It will give all the possible association rules with the confidence of above 50%. Oops, I think I have not executed this one. Yes, 50%, because 50% is something we can use as threshold. Anything above 50% is good. If you use 50% benchmark, means there are 50% chances that the customer is going to buy the recommendations. So we want at least 50% confidence on our recommendation. That's why we use 50%. This can also be changed 50, 60, 70, 80, whatever is as per the requirement, right? Okay. Now, how do we read this table? Forget about leverage and conviction. Okay, forget about leverage and conviction. Just observe, this is the product what customer have bought already, and this is what we are recommending. This is what we are recommending. Clear? Yes, guys? Now, remember the lift was actually considering the individual support of both X and Y. This is X and this is Y, right? The lift was considering the independent support of X and Y also. Yes, the lift was considering the independent support of X and Y also. right? That's what we were able to capture in left. But right now we already have the independent support. So even if we don't observe the left, we observe these two values, we are good. Make sense? Make sense, guys? Sure. See, remember the association rules where we were having this kind of pattern. The customer have bought the product X and we are recommending the product Y, right? Similarly, this is the X and this is Y as per these rules. The customer have bought these two products and we are recommending these two products on the purchase of these two with the confidence of 66%, right? And how better this rule is? In case of left, we observed the individual confidence, the individual popularity is also being considered. So this individual popularity of support of X and support of Y is something we can also consider, we can also observe by these values, right? Right? Make sense? So we can evaluate how better the rule is by these 1, 2, 3, and 4 values, right? Antecedent support, consequent support, support, and confidence. We can simply evaluate the entire rule based on these 4 values, whether the rule is good or not. Yes, guys? Make sense? Make sense? So again, let me summarize what all we have done. We have collected the data. We have transformed it to a transaction encoder. We simply transform the data in a favorable structure. Then we dropped those products that were not popular enough. Then we try to observe the possible permutation and combination of the products with some threshold popularity, and then we created all possible association rules that is giving us the left confidence and all those values. Based on those left confidence and everything, we can decide whether to choose or whether to drop that specific rule. Yes, support column gives the support of the antecedent and consequence X and Y. Antecedent support, no. Antecedent support means support of biscuit only, how popular the biscuit was. Consequent support means how popular the bread was. Right? Yes, guys. Clear till here? Clear till here, everyone? Easy? Easy. Now, after this table, we can easily select the rules and make the recommendations. Yes, guys. After this table, we can easily select the rules and make the recommendations. Awesome. Easy. This was easy, guys. This entire case was easy. Yes, this entire case was easy, guys. Perfect. Let me know if anyone have any questions, guys. I hope this recommendation thing is clear, everyone. Tomorrow we will be starting NLP. Tomorrow we will do the NLP. Tomorrow we will be doing NLP. Collaborative filtering is something we do over neural networks. So that is the approach that we can only discuss once we are good with the neural network based approach. If confidence is more, it is good to recommend, yes, but make sure the antecedent support and consequent support should also be good, right? See, this is having the 100% confidence, but the support are very less, means the products are very less popular in this case. So that is also something we need to consider. Along with the confidence, we need to consider the consequent and antecedent supports as well. Clear? Yes, we are done for the today's agenda. If there are any questions, we will be talking about that DAT thing also. If there are any other questions, we can stay, we can discuss. Otherwise, we are good to drop off. When to use regression and when to use classification. Okay, so whenever the target variable is continuous, we use regression. Whenever the target variable is categorical, we use classification, right? When the target variable is continuous, means we want to predict something that is in a range, that is a regression problem. Otherwise, it's a classification problem. Okay, perfect. Yes. So, is there any other question? Okay, now we can talk about the DAT issue. I think Leela was asking about the DAT thing. You there? Yeah, sure. So I just need a small favor. Can you please help me with your AnyDesk ID so that I can access your system? If okay, you can share your screen, but I won't be able to operate. But in case you can help me with your AnyDesk ID, I can actually take access and I can I can check. You can quickly. Okay, thanks. Perfect. Uh, am I giving the right ID? Oops. Yeah. Okay. Awesome. Can you please navigate me to the code? Okay, that's perfect. Just copy it and execute it there. File not found. Okay. So, can you please show me in File Explorer where is the file? Movies.csv, movies.data. So it's right there in the root. And where is the where is the notebook you are using? Perfect. Okay, so just leave it to me. Give me a moment. So if you remove this path and try to execute, this worked. Yes? Easy? Now, okay, perfect. I got you. See, let me tell you what was the problem. If you are getting Unicode decode error, that means the function is not able to decode the file, right? If you are getting Unicode decode error. So if I change anything from here, let's say I just remove the encoding part. Okay, if I remove the encoding here, if I simply remove the encoding here, okay, so in this case it will give Unicode decode error. Unicode decode error. This error means the CSV function or read table function is unable to decode the data. So that is something wrong with the function. That means there is something wrong with the function, right? But earlier it was giving the file not found error. File not found means the function is unable to locate the movies.dat file, right? The function was unable to locate the movies.dat file. So that means there is something wrong with the path. There is something wrong in accessing the file. Got it? Here also you are getting Unicode decode error. Wait a second. Let me just check what's wrong. If we remove this entire thing, it should work in that case. Okay, okay. So can you just copy the encoding here as well? The encoding, what encoding you have used in the other file, ISO, whatever it was. Okay. Okay, 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 okay. Yes, that is also something you can work. Okay. So this code is also not working? Yes, can you please execute? Syntax error. So first of all, it is giving the syntax error. Perfect. So in that case, just use R before every path. Just give R before every path. Now it's giving file not found error. File not found error for movies data. Where is the movies data? Here. So you just, everything is available in the same folder, right? Okay, okay. Let me try to change and execute the code. Perfect. Now here we have users.csv, and then we have ratings.csv. Okay. Movies.readcsv, you are getting the encoding error. Mm-hmm. Okay. Still not working. Wait, let me try one more thing. Just a sec. Oops, my bad. Okay. It's, I hope it's done. Oops. Yes. Perfect. It's done. Awesome. It happens. No worries. Oh, okay. Perfect. So awesome. That's done. I'm leaving the NDS now. Perfect. Is there anything else? Anyone? Perfect, guys. Thank you all. Thank you, everyone. Tomorrow we'll be doing NLP, and then we will be having one day left. So let's see. We are almost done with the entire syllabus, so we can start, exploring the projects and everything. Tomorrow we'll finish the NLP also, and then the last day we'll talk about the evaluation, the deployment and other things. That's everything, guys. That's everything for the day. Thank you, everyone. Thank you. Bye bye. Take care. Stay safe. See you tomorrow.
Thank you, sir, for this wonderful session, and thank you all for your participation. I request everyone to kindly fill the feedback survey form and share your feedback regarding today's session. Thank you all. Take care.